Hey guys, so last video we talked about converting logarithmic functions to exponential functions, and that will be able to help you whenever you turn around and graph. And I just wanted to point this out before we looked at change of base, is that notice whenever this is from a prior video that we did, is that for instance up here I started with y equals 1.1. If I find the inverse of that function, not even converting it to a logarithm, if I just find that inverse, then I can graph it. And that may be easier for you to be able to plot out points than if you were doing it by hand. And that's why I said before we honestly look at graphing, we need to be able to look at how to convert our exponential function to a logarithmic function. And that is finding the inverse of it and then being able to write it as a logarithm. I will turn around and say though, the same applies with logarithmic functions as it does in dealing with exponential functions. I would advise you to use technology because your numbers can go from very small to very large, and it's very hard to scale your graph and then be able to graph by hand an accurate graph. That being said, what I would like to talk to you about are your calculators and change of base formula. So for logarithmic functions, the log of x, whenever it's simply written like that, means that there's an understood base 10 with it. We call that a common log. This, that is an L. So ln means natural log. So the natural log of x means that it's log base number e. That's the number e right there. So natural log means log base number e, and we call that a natural log. And something for you to remember here is the natural log of 1 equals 0, and the natural log of e equals 1. So here's some just, we can have this type of problem, and to use our calculator, a lot of our calculators won't be able to solve it. Now you get to some more of the sophisticated calculators and it'll allow you to put in different bases. But for the most part, if you have a basic calculator, what it's going to go off of is log base 10 or log base number e, which is natural log. So if you have one of those, it's important to be able to know how to change the base. And this is what we have, just in case we have some problems like this written down. So log base b of capital M. We can find that value by turning around and saying, okay, log base a, and see this is log base a. You make it 10 or you make it the number e. Either way. And then it turns into a quotient, capital M over b. So here's our problem. I have log base 12 of 3. Well, I can solve this either way. I can make it to base 10, and I went ahead and wrote the 10 in there so that way you actually visualize it. But again, log base 10 is simply written as log of whatever it is. So log base 10 of 3 over log base 10 of 12. Again, capital M, lowercase b, right there, lowercase b, it's 12. That's where I got my values. And how I would actually write it without writing that in there is log of 3 over log of 12. And that gives me a numeric value of that. Or I could use natural logs. I could say the natural log of 3 divided by the natural log of 12 gives me 0.442, which is simply log of log base number e of 3, log base number e of 12. So let's look at some examples. So here's my formula, log base b of m, and how I convert that. Again, a is going to either be 10 or the number e. And here's the first one I did for us, and what we're doing is solve using common logarithms. This is m, so m's in the numerator, This is lowercase b. It's in the denominator. So I just use my calculator. I say log of 100 divided by log of 4, and it's approximately, I guess I shouldn't have made an equal sign. It's approximately 3.322. So what I would like for you to do, pause the video, and I would like for you to solve these two problems. Alright, so I have this automatically. I know this is the first thing I can write down, and I know this is going to be to 10, or I could do natural logs also, but this is going to be an understood 10 written here as my base. And then I just take m, which is 20, and b, which is 3, and then I solve. Okay, so we're going to use our calculator and we're going to look at this. Alright, so I guess in order, I got to turn on my light. I'm still don't know all this movie making light projection stuff. That's the best way it'll show up on here. So what I had was log base 3 of 20. So this is my log button. So log 20 divided by log of 3. I'll take it out 3 places. So I say 2.727, and it's approximate, not equal to. Now with mine, I have the ability to be able to plug that actually in, but let's look at this. Let's look at the natural log of 20 divided by the natural log of 3. Same answer. Then I'll use the actual function. Let's see, I'm sorry for that glare on the calculator. I'll pull this over so I'm going to see if that'll help. Okay, for mine, what I have is that on the TI you can actually type that in, so we'll go, and I can actually type in that base. So it was a base of 3 to 20. So if you don't have this function, you can easily use this ability to change bases, and you will still have the same answers. Okay, for the next one, I have, and I already know this portion, so I'll just write that in. That's easy to do. Now, and you can even look at it like this. The bigger is the numerator, and the smaller is the denominator. So I'm going to say log 0.3 divided by log of 100. Now take it out 3 places. And we'll do 100 and 0.3. Same answer. And I could do the same with natural log. Okay, so the use of technology, as long as you understand what it is that you're doing, I firmly believe in that. Use the technology to be able to help you visualize and see and understand. Don't just use the technology to compensate for a gap of knowledge. So with that being said, for graphing of your logarithmic functions, utilize your technology. Save that time and the difficulty. Use your TI-8384 or Desmos.com or the Desmos app. And ladies and gentlemen, that completes our lessons on logarithms. Watch your publisher's videos, critically think and structure your homework, and good luck on your homework problems.